Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on temporary, permanent and total hardness of water. So before going to discuss these problems, mainly we should remember why all these hardness causing salts converted into equivalent of CaCO3. This is most important for numerical calculation purpose based on this temporary and permanent and total hardness of water. So now let's discuss expression of hardness in terms of equivalent of CaCO3. So what is that meaning? All the hardness causing salts, for example, calcium, magnesium ions of bicarbonates, chlorides, sulfates, nitrates which are present in water. So all the hardness causing salts which are present in water all are converted into CaCO3 equivalent. Why you have to convert all these hardness causing salts in CaCO3 equivalent? Because CaCO3 its molecular weight is 100 and equivalent weight is 50. So the calculation in water analysis it can be simplified. That means this calcium carbonate is molecular weight is 100 and equivalent weight is 50 and it is highly insoluble in water. So it makes calculation is very easy. So all the hardness causing salts which are present in that water, so all are we can convert it into CaCO3 equivalent. So it makes calculation is very easy. So how can we convert all the hardness causing salts in CaCO3 equivalent? So by using this formula, so weight or amount of hardness causing salt, by molecular weight of hardness causing salt into 100. So for example, 50 ppm of calcium bicarbonate present in water. So here, what is the weight of hardness causing salt? That means weight of calcium bicarbonate is 50 ppm of calcium bicarbonate. So the amount of hardness causing salt here, hardness causing salt means calcium bicarbonate. So the amount of calcium bicarbonate is 50 by molecular weight of hardness causing salt is 162. So molecular weight of calcium bicarbonate is 162 into 100. So here 100 is the molecular weight of calcium carbonate. So in this way, all the hardness causing salts which are present in water, we can convert it into CaCO3 equivalent because it makes calculation is very easy. And the CaCO3 is highly insoluble in water and molecular weight is 100 and equivalent weight is 50. So the calculation in water analysis it can be simplified. So now let's discuss the molecular weight of hardness producing salts or hardness causing salts. So these molecular weights are most important for numerical calculation purpose. Generally hardness causing salts are calcium bicarbonate, magnesium bicarbonate, calcium sulfate, magnesium sulfate, calcium carbonate and calcium, magnesium, chloride, sulfates of calcium and magnesium. So these molecular weights of all these hardness causing salts are most important for numerical point of view. So here calcium bicarbonate molecular weight is 162 and magnesium bicarbonate is 146, magnesium nitrate 148 and magnesium sulfate 120 and magnesium carbonate 84, magnesium chloride 95 and calcium nitrate molecular weight is 164 and calcium carbonate is 100. So just now we discussed already, calcium carbonate molecular weight is 100 and equivalent is weight is 50. So it makes calculation is very easy. That's why all the hardness causing salts converted into CaCO3. So it makes calculation is very easy. So calcium carbonate molecular weight is 100 and calcium sulfate molecular weight is 136 and calcium chloride molecular weight is 111, calcium 40, magnesium 24. So these are the molecular weights of hardness causing salts or hardness producing salts. Now we'll discuss numericals based on that permanent, temporary and total hardness of water. So here calculate the temporary and permanent. Calculate the temporary and permanent hardness of water sample containing magnesium bicarbonate is equal 7.3 milligram per liter. 7.3 milligram per liter. And calcium bicarbonate is 16.2 milligram per liter. 16.2 milligram per liter. And magnesium chloride weight is 9.5 milligram per liter. And calcium sulfate is 13.6 milligram per liter. So this much amount of these hardness causing salts present in water. So now calculate the temporary and permanent hardness of water. So what is the first step? We should remember all the hardness causing salts which are present in water, we can convert it into CaCO3 equivalent or equivalent of CaCO3. So how can we convert? By using this formula, weight of hardness causing salt by molecular weight of hardness causing salt. Into 100. So by using this formula, we can convert it all the hardness causing salts which are present in the data or in the problem. We can convert it into equivalent of CaCO3. So here, which type of hardness causing salts present in that water? Magnesium bicarbonate, calcium bicarbonate, magnesium chloride and calcium sulfate. So what are the amounts of these hardness causing salts present in the given water? Magnesium bicarbonate is 7.3 and calcium bicarbonate is 16.2. Magnesium chloride is 9.5. Calcium sulfate is 13.6. So these are the these are the weights of hardness causing salts present in that given water or given in that data. So molecular weights of these hardness causing salts are magnesium bicarbonate is 146, calcium bicarbonate is 162, magnesium chloride is 95, calcium sulfate is 136. So now you can calculate the equivalent to CaCO3. So by using this formula, weight of hardness causing salt by molecular weight of hardness causing salt into 100. So your weight of magnesium bicarbonate is 7.3 by molecular weight of magnesium bicarbonate is 146 by 100. So 7.3 by 146 into 100. It's equal 5 milligram per liter. And next one is calcium bicarbonate. So its weight is 16.2 given in the data. So 16.2 by molecular weight of calcium bicarbonate is 162. So 16.2 by 162 into 100, it's equal 10 milligram per liter. 10 milligram per liter. Next, magnesium chloride. So the weight of magnesium chloride is 9.5 by molecular weight of magnesium chloride is 95. So 9.5 by 95 into 100, it's equal 10 milligram per liter. Next, last one is calcium sulfate. So the weight of calcium sulfate is 13.6 and molecular weight of calcium sulfate is 136. So 13.6 by 136 into 100, it's equal 10 milligram per liter. So this is the first step. First, all the hardness causing salts which are present in water, all these are converted into CaCO3 equivalent terms. So now you can identify the temporary hardness causing salts and permanent hardness causing salt in that given data. So temporary hardness causing salts are present in this water is magnesium bicarbonate and calcium bicarbonate. Magnesium bicarbonate and calcium bicarbonate. So magnesium bicarbonate value is 5 and calcium bicarbonate is 10. So it's equal 15 milligram per liter or it's equal 15 ppm. So permanent hardness of water. So permanent hardness causing salts present in that water is magnesium chloride and calcium sulfate. So magnesium chloride value after converting the equivalent of CaCO3 is 10 and calcium sulfate is 10. So 10 plus 10 it's equal 20 milligram per liter or it's equal 20 ppm. So temporary hardness of given water is 15 ppm and permanent hardness of given water is 20 ppm. Now you can calculate the second problem based on the temporary and permanent and total hardness of given water. So here calculate the amount of temporary and permanent hardness of water sample in degree of clerks, a degree of French, degree of clerk and degree of French and milligram per liter. So these are the water units of water, that is degree of clerk, degree of French and milligram per liter. So which contain the following impurities are calcium bicarbonate equal 121.5. Calcium bicarbonate is 121.5 ppm and magnesium bicarbonate is 116.8 ppm and magnesium chloride is 79.6 ppm and calcium sulfate is 102 ppm. So now calculate the temporary and permanent hardness of water, and after that we can convert it into degree of clerk, degree of French and milligram per liter. So first we converted all the hardness causing salt in CaCO3 equivalent terms. So already we know the formula. How can we convert all the hardness causing salt in a calcium carbonate equivalent or equivalent of CaCO3? So it's equal weight of hardness causing salt by molecular weight of hardness causing salt into 100. So here calcium bicarbonate, what is the weight of this calcium bicarbonate? 121.5. So calcium bicarbonate according to data its amount is 121.5 and magnesium bicarbonate weight is 116.8. Magnesium bicarbonate is 116.8 ppm. And next magnesium chloride weight in the data according to data its value is 79.6. 79.6 and calcium sulfate present in that given water is 102 ppm. So the weights of hardness causing salts present in water is calcium bicarbonate, magnesium bicarbonate and magnesium chloride and calcium sulfates are 121.5 and 116.8, 79.6 and 102. So what are the molecular weights of these hardness causing salts present in water? So calcium bicarbonate molecular weight is 162 and magnesium bicarbonate molecular weight is 146 and magnesium chloride molecular weight is 95 and calcium sulfate is 136. So now I can convert it into calcium carbonate equivalent. So by using what is the formula we are using here? Amount of hardness causing salt present in water by molecular weight of hardness causing salt into 100. So your weight of calcium bicarbonate is 121.5 and by molecular weight of calcium bicarbonate is 162. So 121.5 by 162 into 100 is equal 75 ppm. 75 ppm. Now let's say magnesium bicarbonate, we can convert it into amount of equivalent to CaCO3. So what is the weight of magnesium bicarbonate? 116.8 by what is the molecular weight of magnesium bicarbonate? Its value is 146. So 116.8 by 146 into 100 it's equal 80 ppm. It's equal 80 ppm. And next magnesium chloride, its weight is 79.6 by molecular weight of magnesium chloride is 95. So 79.6 by 95 into 100 it's equal 3.37 ppm. So now I can convert it calcium sulfate CaSO4 in amounts of equivalent to CaCO3 or converted into equivalent of CaCO3. So weight of calcium sulfate is 102 by molecular weight of calcium sulfate is 136. So 102 by 136 into 100 is equal 75 ppm. So in this way we can convert it all the hardness causing salts which are present in water. We can convert it into CaCO3 equivalent by using the formula weight of hardness causing salt by molecular weight of hardness causing salt into 100. Now you can calculate the temporary hardness of given water. So temporary hardness causing salts present in that given water is calcium bicarbonate and magnesium bicarbonate. So after converting these salts in a calcium carbonate equivalent, you'll get 75 and 80. So 75 plus 80 is equal 155 ppm. So temporary hardness of given water is 155 ppm. So now you can convert it into milligram per liter, degree of Clerk, degree of French. So what is the basic relationship between all the units? Generally 1 ppm equals 1 milligram per liter. It's equal 0.07 degree of Clerk and it's equal 0.1 French degree. So this is a basic relationship between all the units of hardness. 1 ppm equal 1 milligram per liter and it's equal 0.07 Clerk degree and it's equal 0.1 French degree. These are the basic relationship between all the units of hardness. So now here getting temporary hardness of water is 155 ppm. So it's equal to how many milligram per liter? So generally 1 ppm equal 1 milligram per liter. So 155 ppm equal, generally ppm equal milligram per liter, both are equal. So 155 ppm equal 155 milligram per liter. Then it's 155 ppm equal how many Clerk's degrees? So 155 into 0.07, it's equal 10.85 Clerk degrees. 10.85 Clerk degrees. Then converted into French degrees. So 155 into 0.1 French degree. Here 1 ppm equals 0.1 French degree. So 155 ppm equal how many French degrees? So 155 into 0.1, it's equal 15.5 French degrees. Next you can calculate the permanent hardness of given water. So permanent hardness causing salts present in given water is magnesium chloride and calcium sulfate. So after converting this calcium carbonate equivalent, we'll get the values of magnesium chloride is 10 and calcium sulfate is 5. So total it's equal 15 milligram per liter. It's equal 15 milligram per liter. Permanent hardness of given water is 15 milligram per liter. So it's equal how many ppm? Mathematically already we know that 1 ppm equal 1 milligram per liter. So 15 milligram per liter is equal 15 ppm. 15 ppm or 15 ppm equal 15 milligram per liter. Mathematically ppm and milligram per liter both are equal. And how many Clerk's degrees 15 ppm equal to? So 15 into 0.07 Clerk degree. So it's equal 1.05 Clerk's degrees. 1.05 Clerk's degree. And next it's equal how many French degrees? So 15 into 0.1 French degree, it's equal 1.5. It's equal 1.5 French degrees. So temporary hardness of given water is 155 ppm and permanent hardness of given water is 15 milligram per liter. Next, one more problem based on this hardness, total temporary and permanent hardness of water. So calculate the temporary and total hardness of water sample containing the following hardness causing salts in that water. Magnesium bicarbonate is 73 milligram per liter and calcium bicarbonate is 162 milligram per liter and magnesium chloride is 95 milligram per liter and calcium sulfate is 136 milligram per liter. So now you can convert the CaCO3 equivalent. Because why we are converting all the hardness causing salt in CaCO3 equivalent? Because calcium carbonate molecular weight is 100 and equivalent weight is 50 and it is highly insoluble in water. So that's why we can converted all the hardness causing salt in CaCO3 equivalent because it makes calculation is very easy. So what are the hardness causing salts present in that given water? Magnesium bicarbonate, calcium bicarbonate, magnesium chloride and calcium sulfate. So what are the weights of these hardness causing salts present in that given water? So magnesium bicarbonate is 73 and calcium bicarbonate is 162. Magnesium chloride is 95 and calcium sulfate is 136. 136. So molecular weights of given hardness causing salts. So magnesium bicarbonate hardness causing salt is magnesium bicarbonate. Molecular weight of magnesium bicarbonate is 146 and calcium bicarbonate molecular weight is 162 and molecular weight of magnesium chloride and calcium sulfates are 95 and 136. So then we can convert it into equivalent of CaCO3. So here what is the formula you are using? Already we discussed. What is that? Weight of hardness causing salt by molecular weight of hardness causing salt into 100. So here 100 is the molecular weight of hardness causing salt, molecular weight of calcium carbonate. So here weight of magnesium bicarbonate is 73 and molecular weight of magnesium bicarbonate is 146. So 73 by 146 into 100 is equal 50 milligram per liter. 50 milligram per liter. Next, calcium bicarbonate. You can convert it into equivalent of CaCO3. So weight of calcium bicarbonate is 162. By molecular weight of calcium bicarbonate is same 162 into 100. We'll get 100 milligram per liter. And next, magnesium chloride. Weight of magnesium chloride is 95 and molecular weight of magnesium chloride is 95. So 95 by 95 into 100 is equal 10 milligram per liter. 10 milligram per liter. Next, calcium sulfate. So what is the weight of calcium sulfate given that problem? 136. And molecular weight of calcium sulfate is 136. So 136 by 136 into 100 is equal 10 milligram per liter. So in this way you can convert it all the hardness causing salts in CaCO3 equivalents. Now you can calculate the temporary hardness of given water. So temporary hardness causing salts are calcium bicarbonate and magnesium bicarbonates. After conversion, calcium carbonate equivalent will get 100 plus 50. So 100 plus 50 is equal 150 milligram per liter or ppm. 150 ppm. So temporary hardness of given water is 150 ppm. Next, permanent hardness of given water is, here permanent hardness causing salts present in that water is magnesium chloride and calcium sulfate. So magnesium chloride and calcium sulfate after converting this calcium carbonate equivalent, the values are magnesium chloride is 100 and calcium sulfate is 100. So 100 plus 100 is equal to 200 milligram per liter or ppm. So total hardness is equal. Total hardness means temporary hardness and permanent hardness. So temporary hardness is 150 ppm and permanent hardness of given water is 200 ppm. So total hardness is equal 150 plus 200 is equal 350 milligram per liter or 350 ppm. So the temporary hardness of given water is 150 milligram per liter or 150 ppm and permanent hardness of given water is 200 milligram per liter or 200 ppm and total hardness of given water is 350 milligram per liter or 350 ppm. Now we'll discuss one more problem based on that. Total hardness, permanent hardness and temporary hardness of given water. So one more problem we'll discuss now. 1 liter of water from an underground reservoir in Tirupati town in Andhra Pradesh. So show the following analysis for the contents. So magnesium bicarbonate is equal 42 milligrams. Magnesium bicarbonate is equal 42 milligrams and calcium bicarbonate is 146 milligrams and calcium chloride is 71 milligrams and magnesium sulfate is 48 milligrams. So now calculate the temporary, permanent and total hardness of this sample of 10,000 liters of water. 10,000 liters of water. So first we can convert all the hardness causing salts which are present in water. So that means magnesium bicarbonate, calcium bicarbonate, calcium chloride and magnesium sulfate. So all these are converted into calcium carbonate equivalents or equivalent of calcium carbonate. So how can we convert this equivalent of CaCO3? So expression of hardness in terms of CaCO3 is equal amount or weight of hardness causing salt by molecular weight of hardness causing salt into 100. So by using this formula, we can convert all the hardness causing salts which are present in water. We can convert it into equivalent of CaCO3 because it makes calculation is very easy. That's why we convert it into CaCO3 equivalent. So now we'll convert this magnesium bicarbonate weight is 42. So magnesium bicarbonate weight is 42 and molecular weight is 146. So what is the formula we are using here? Weight of hardness causing salt by molecular weight of hardness causing salt into 100. So weight is 42 and molecular weight is 146 into 100. So it's equal 28.76 ppm. And next we can convert calcium bicarbonate in equivalent of CaCO3. So here weight of calcium bicarbonate is 146 and molecular weight of calcium bicarbonate is 162. So 146 by 162 into 100 is equal 90.12 ppm. Next we can convert it to magnesium sulfate. So what is the weight of magnesium sulfate given in that problem? 48. So 48 by molecular weight of magnesium sulfate is 120. So 48 by 120 into 100 is equal 40 ppm. Next one is calcium chloride. So then we converted calcium chloride in calcium carbonate equivalent. So weight of calcium chloride is 71 and molecular weight of calcium chloride is 111. So 71 by 111 into 100 is equal 63.96 ppm. ppm means here parts per million, units of hardness. So now we can calculate the temporary hardness of given water. So what are the temporary hardness causing salts present in that water? So these two calcium, magnesium bicarbonates are present in that water. These are the temporary hardness causing salt present in that given water. So after conversion calcium carbonate equivalent, magnesium bicarbonate value is 28.76 and calcium bicarbonate value is 90.12. So it's equal 118.88 ppm. 118.88 ppm. Now I can calculate the permanent hardness of water. So permanent hardness causing salts whatever which are present in that given water is magnesium sulfate and calcium chloride. So calcium chloride value after conversion into equivalent of CaCO3 is 40 and magnesium sulfate is magnesium sulfate value is 40 and calcium chloride value is 63.96. So it's equal 103.96 ppm. So the total hardness equal, total hardness means temporary hardness and permanent hardness. That means calcium, magnesium ions of bicarbonates, chlorides, sulfates which are present in the given water. So its value is temporary hardness equal 118.88 and permanent hardness equal 103.96. So total hardness equal 222.84 ppm. So then we can convert it into permanent hardness and temporary and total hardness in 10,000 liters of water. So how can we convert this 10,000 liters of water? So your permanent hardness equal, permanent hardness of given water is 103.96. 103.96 into 10,000. So it's equal 10,39,600 ppm will get. 10,39,600 ppm. Next, temporary hardness, we can convert it into 10,000 liters of water. How much amount of temporary hardness present in the 10,000 liters of water? So temporary hardness of given water is 118.88. 118.88. So then we convert how much amount of temporary hardness present in the 10,000 liters of water? So 118.88 into 10,000 it's equal 11,88,800 ppm. So now you can calculate the total hardness of given water. So total hardness of given water is 222.84. So this total hardness converted into 10,000 liters of water. So 222.84 into 10,000, it's equal 22,28,400 ppm. So permanent hardness of given water is 103.96. Temporary hardness of given water is 222.84, and temporary hardness of given water is 118.88, and total hardness is 222.84 ppm. So in this session we learn about how can we calculate the temporary hardness and permanent hardness and total hardness of given water, and how can we convert this hardness, temporary, permanent and total hardness in degree of French and ppm. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.